Good morning, students. Myself, Vijay Shankar from the ECE department, Chevrolet Engineering College. Today, we are going to discuss about the examples in the fourth unit, that is magnetostatics. Yesterday, we started magnetostatic examples, and we did the 5 examples. Now, we can go for another example. That is, obtain the expression for H bar in all the regions of a cylindrical conductor carries a direct current I and its radius is R. Plot the variation of H bar against the distance R from the center of the conductor. So we need to, they are asking that obtain the expression for the H bar in all the regions of the cylindrical coordinates carrying the current I is there and the radius R, and plot the variation of H bar against the distance R from the center of the conductor. Let the cylindrical conductor a radius of R. So here the radius of R is there. Now outermost is a radius R. Carries a uniform direct current I amperes. It is placed along the z-axis, has infinite length. The H bar is obtained to consider the two regions. One region is R is less than the R first region. Let us take that is R is less than, the small r is less than the R, means inside that is. And current carrying the z-axis center, as the current I flows uniformly, it flows across the cross-sectional area pi r square, the total radius. While the closed path encloses the part of the current which passes across the cross-sectional area of pi r square, as the current is, current I enclosed is equal to, inside the radius is a pi r square, the outside with the radius of capital R, that is a pi capital R square. So I enclosed is equal to I into R square by R square. The small r square by R square. And it has a H bar, they are asking H bar is equal to H phi into A phi bar. In the cylindrical coordinate system, DL bar is equal to a differential length along the A phi bar. That is only the R into D phi. So actually DL bar is equal to DR into AR bar plus R into D phi into A phi bar plus DZ into AZ bar. Okay, this is a DL bar, that is differential length in the cylindrical coordinate system. So H bar component we take in the phi direction only. The A phi bar is H phi. So H bar dot DL bar is equal to the Ampere's circuit law according to I is equal to H bar dot DL bar as integral. H bar is H phi into A phi bar dot DL bar. DL bar is also into the A phi bar, R into D phi A phi bar. A phi bar and A phi bar get the values of 1. H phi into R into D phi. We need to find the current I is equal to, according to the Ampere circuit law, we know H bar dot DL bar. So what is the H bar dot DL bar? We got H phi into R into D phi as an of integral I is equal to, according to the Ampere's circuit law. Phi, the phi is varies from the 0 to 2 pi in the cylindrical coordinate system. R is a 0 to infinite and Z is a minus infinite to infinite. What is I enclosed? We got as a I enclosed, we can substitute here. I enclosed is equal to I into small r square by the capital R square is equal to H phi, and the R is a constant with the integral of phi is equal to 0 to 2 pi D phi. Okay, so I into R square by the capital R square is equal to H phi R, apply the integral of D phi, so 1 is phi, upper limit is a 2 pi, get the 2 pi here. Got it, my students? Here the square term is there when one on R is get cancelled. So we need to find H phi is equal to I by IR also there, IR, and 2 pi will get the cross multiplied 2 pi into R square. Okay, then H bar is equal to H bar is H phi IR 2 pi R square into A phi bar. Okay, H bar is equal. Got it, my students? H bar is in terms of R small r into capital R square, the A phi bar, ampere per meter square. But inside the conductor, H bar is proportional to the R, and on the surface R is equal to R, hence H bar becomes H bar is equal to I by the 2 pi R. When it is a H bar is proportional to the R, and that R is also equal to the R, then H bar is equal to the inner side, it is I, and this also we consider as R 2 pi into R square A phi bar. So 1 R is get cancelled. H bar is equal to I by the 2 pi R into A phi bar. This is a condition for R is less than the capital R. Okay. Now the outside the conductor we can consider there's a small r is there. Now we assume the capital R is inside. A small r with the radius of R, and now it is outside we can consider I is equal to I by 2 pi R into A phi bar for the R is greater than the conductor is infinite length along the Z axis is carrying, that is a H bar is proportional to the 1 by R. See here the H bar is proportional to the 1 by R. So now I can draw from below the R is increasing level. Why? Because the R is in the numerator. Okay, slowly if it is increases, R is increases, H bar is also increases. And above the R, it is decreases. The H bar is proportional to the R. See in this function, if I use this function, consider this is a constant value. So H bar is proportional to R. When the outside it is H bar is considered is I by 2 pi is a constant. H bar is proportional to 1 by R. Means if it is R is increases, H bar is also increases. But here, if R is increases, H bar is a decreases slowly. Okay. According to this, the diagram shown here, you see, from 0 to R, below the R is there, the radius region, R is less than the R, slowly it is increases. As H bar R is increases, small r is increases, H bar is also increases in this region. Coming to the second region, for R is greater than the R, H bar is 1 by R. Within the denominator, R is decreases means H bar is increases. If R is increases here, and it is increases means definitely it is a decreases. When this R is outside and R is inside means that is slowly it is increases, outside is slowly it is a decreases and goes to the zero value. Okay. And coming to the next example, the plane y is equal to 1 carries a current density. A plane y is equal to 1. Y is equal to 1 means at the point 1, the remaining all the values is a 0. X value and the Z value. Current density K bar is equal to 40 AZ bar ampere per meter. Find H bar at the A point is 0, 0, 0 and B point is 1, 5 minus 2. The sheet is located at y is equal to 1, on which K bar is in the AZ bar direction. AZ bar means the upward direction. You see here, this upward direction. Got it, my students? This K bar is equal to 40 into AZ bar. The sheet is located at the y is equal to 1, on which K bar is in the AZ bar direction. The sheet is infinite as shown in the figure. H bar will be in the x direction. H bar will be in the x direction at point 0, 0, 0. Okay. This direction of the K bar is a 1 and the H bar is in the x direction. A plane is in the y direction. At the y is equal to 1 plane. So A n bar is equal to minus A by bar about the current to the point A. You know, this is a formula for the infinite sheet of current. Infinite sheet of current. The previous examples we did the infinite current carrying conductor, a long straight conductor, the DL, and now it is a surface K. The volume is represented as a J value. So 1 by to the K bar cross A n bar. The K bar is given the 40 into AZ bar, and AN is a minus AY bar. So Y is equal to 1 means it is in the negative direction of that one from here. So minus AY bar, the direction. So AZ and AY, AZ and AY, the cross product is a Z and Y is not the order. So minus AX bar will get, already the minus is there, minus it becomes a plus. So 1 by to the 40 AX bar, H bar is equal to 20 AX bar at the point of 0, 0, 0. Okay, my dear students. Now at the point of 1, 5 minus 2. 1, 5 minus 2 means the value of y is the right of the plane of the y is equal to 5 for the B bar. So now you can take this, a point is a positive value. AN bar is equal to AY. So AZ and AY is again, it is a AX only, but the minus AX at 20 AX per ampere per meter. But the origin, the H bar you get the positive. At the point of B, the 1, 5 minus 2, you'll get the H bar is the negative, minus 20 AX bar. Okay. Come to the next value. Next is example. Sorry. In which, in the region R is in between of 0 to 0.5 meters, the cylindrical coordinates, the current density is given. And current density, the A, J bar is equal to 0 elsewhere. Use the ampere circuit law to find the H bar. What is the ampere circuit law is equal to J bar dot ds. J bar dot ds bar. Given that is a J bar is equal in the direction of AZ bar. So J bar is given that is a 4.5 into e power minus 2r into AZ bar. AZ bar. So J is a current density means definitely it is a surface ampere per meter square. Now the ds, differential surface area normal to the Z direction. Z direction means in the cylindrical coordinates, dr is one differential element r into d phi. So r dr d phi, AZ bar is a ds bar is equal to. Again, substitute in the ampere circuit law, the I is equal to integral J bar dot ds bar. J bar is a 4.5 e power minus 2r into AZ bar dot dr r d phi AZ. AZ bar dot AZ bar is equal to 1. So we need to find the current I is equal to 4.5 is a constant, and the integral is a r integral, not the r. The two terms is a r into e power minus 2r dr and integral d phi. The phi we know, the 0 to 2 pi, and r is given, the r is equal to 0 to r, with the radius of r only. Actually, the r to infinite. I consider the r 4.5 and apply here the by parts. The by parts is r into e power minus 2r by r minus 2 minus another time is the integral 1 into the derivative of r e power minus 2r by the minus 2, and it is a dr here, and integral d phi is a 5 and upper limit is a 2 pi only, the 2 pi, and again it is a 0 to r. Next is the current I is equal to 4.5 into the 2 pi we got as integral of d phi, and other way the r into e power minus 2r by minus 2. Already the minus into minus is a plus. 1 by 2 is already there. E power minus 2r by minus 2 with upper limit is r and lower limit is 0. That is equal to 4.5 into 2 is 9. Okay, my dear students. And the pi, or you can write after simplification, it is a 2 pi into 4.5 whole multiply with the upper limit you can substitute minus r e power minus 2r by r by 2, and here also you can substitute, it is a minus 1 by 4 into e power minus 2r, r in the place in the r only, and you can substitute r is equal to 0 here. The second term here the minus is there, it becomes a plus for lower limit the 0, and already here also the minus it becomes a plus 1 by 4 into e power 0 is a 1. Okay, now it is this I is equal to the total value of I is equal to 9 pi, the 2 into 4.5 is a 9 pi minus r e power minus 2r by r minus 1 by 4 e power minus, here the minus is there, minus friends, minus and 1 by 4. Got it? You can take the common of 4 in all the terms. 1 minus e power 2r, and other one is 2 is 2 into r into e power minus 2. At r is equal to 0.5. As it is r is equal to 0.5, r is equal to 0.5, the current I is equal to 1.867 amperes. Got it, my district? Now consider a closed path with r is greater than or equal to 0.5, such a closed I is equal to 1.867 amperes. According to the ampere circuit law, and that h bar dot dl bar is equal to I we got 1.8676 amperes, and dl bar is a phi direction, and h bar is equal to a phi. Now h phi into r d phi is upper limit is a 2 pi, will get is equal to 1.8676. So h phi is equal to 1.8676 by 2 pi r. The simplification by substituting h phi is equal to, what is the value of the 0.2972 by r. Therefore, h bar is equal to, it's in the direction of a phi bar. Okay, that is for r is greater than 0.5 meters. Got it, my students? Coming to the next example. A Z directed current distributed is given by J bar is given for R is less than or equal to A. Find B bar at point is R is greater than A. So given that is a point R less than or equal to A, then they're asking that is a find B bar at any point R is greater than or equal using ampere circuit. First of all, you can find the current I bar is equal to J bar dot ds bar, J bar dot ds bar, and it is directed to the current in the Z direction, means considered as a Z bar out, AZ bar direction. J bar is in the AZ bar direction. Here they didn't given that is a J bar is equal to R square plus mu into R only. It's not showing that is a AZ, but there are here saying a Z directed current distribution is given by. So I is equal to J bar means R square plus mu R AZ bar. The direction is AZ bar dot the differential surface area is also in the direction of R. Z bar means R dr d phi AZ bar only. So again the same thing here. AZ bar dot AZ bar is a 1. The integral R square plus mu into R dr d phi AZ bar dot AZ bar is equal to 1. And integral is a R integral and the phi integral. Multiply this R square dr plus integral mu into R cube minus which here mu into R square dr. Okay. And then the d phi also. The integral d phi is at 2 pi. Multiply this one. Therefore, the I is equal to R cube is R power 4 by 4 plus and mu into R cube by 3, and you can apply the limits is a 0 to R and to 2 pi. That is equal to 2 pi into, first of all, you can substitute R as a R value. As of R is equal to A, we're saying it is an equal to condition also. The I is equal to, it becomes of 2 pi into A power 4 by 4 plus mu into A cube by 3. A cube by 3 value. And when I consider it is a R is equal to A. Got it, my students? So it find the substitute this value in the ampere circuit law. I is equal to H bar dot DL bar as an integral. The similar fashion you can find the H bar dot DL bar is 2 pi R into H phi is equal to this function. That is a 2 pi into as of A power 4 by 4 plus mu into A cube by 3. Why you got this H 2 pi R into H phi? The integral H phi R into D phi. DL bar is in the phi direction R into D phi. H bar is the phi direction H phi into A phi. A phi dot A phi is a 1. And the remaining is applying the integral with the D phi is a 2 pi R into H phi. Okay. So both sides at 2 pi is get cancelled. H phi is equal to, we got as I, not the I, 1 by the 2 pi get is take the function, not take the R only. If I take R, A power 4 by 4 plus mu into A cube by 3. This is a function of H phi is equal to 1 by R. Here they take that is a LCM is a 12, and here the 3 times, and here the 4 times. By 12 means A power 4 is multiplied with the 3 minus 6. Here there is a wrong is there. And here the 2 is also the 2 pi. The 2 pi get cancelled. The 4 into A power 4. That is not the 4 into A power 4 minus 4. It is 3 into A power 4 and the 4 into, I think, 3 4, you can multiply either 3. So the h bar is equal to the function, whatever we have, simplified function, or we can write this as h bar is equal to h phi into a phi bar. What is the h phi? The 1 by r into, I'm directly writing it in terms of not taking the LCM, mu a cube by 3 into a phi bar. Okay, is the h bar is equal to ampere per meter square. And assume that the mu is equal to permeability. B bar we got mu into h bar. So mu bar get cancelled. I can multiply that function. Weber per meter cube as magnetic flux, and ampere per meter is a magnetic field. Got it, my dear students? Coming to the next example. H bar due to a current, H bar due to a current source is given. Source is given by the H bar is equal to X bar coefficient is Y cos alpha X. AZ bar coefficient is Y plus e power X. Describe the current density over the YZ plane. Current density means J bar as to the Z bar. See, according to the Ampere circuit law, the Maxwell's equation, the previously we did that it is a H bar dot DL bar is equal to I. Okay, and integral H bar dot DL bar is equal to I is in terms of J is J bar dot DS bar. J bar dot DS bar. When it is in the line integral is converted to surface integral, cross product we can apply. Del cross H bar dot DS bar is equal to integral J bar dot DS bar. The both sides is a surface integral with a dot product. So remove that integral surface integral. Then we'll get the del cross H bar is equal to J bar. This is one of the Maxwell's equation also. Got the Ampere circuit del cross H bar is equal to J bar. What is the del cross H bar? Is a dead value, the AX bar, AY bar in the Cartesian coordinate system, AZ bar, del. It is dou by dou X, dou by dou Y, and dou by dou Z. And H values, AX bar coefficient is a HX, AY bar coefficient is a HY, and AZ bar coefficient is a HZ. What is a HX? HX value, AX bar coefficient, I am saying. What is the AX bar coefficient? Now we can substitute this as AX bar, AY bar, and AZ bar. So applying the del cross product with del cross H bar, dou by dou X, dou by dou Y, and dou by dou Z. Now see, in the H bar, that is a HX, HY, and HZ. Is a HX is a AX bar coefficient. What is the AX bar coefficient given? The Y cos alpha X. There is no any HY because the AY bar coefficient is a 0. And AZ bar coefficient is a Y plus e power X. So now we can apply the cross product here. That is equal to AX bar into, and I'm taking the AX bar, the dou Z by dou it is a 0. Dou by dou Y of Y plus e power X. Okay, this is only the term. Next, minus AY bar into, this is a function. First term is a 0, the second term is a minus dou by dou Y of Y into cos alpha X. Okay, plus AZ bar into AZ bar. The first term is a 0. It is a ZZ bar only, my students. Actually, the thing is a minus ZZ bar plus AZ bar. Now minus AY bar. AY bar, it is dou by dou x of y plus e power x minus dou by dou z of y cos alpha x. Okay, my students. This is a AZ bar. AZ bar is, we'll get the first term is a 0 and second term. So AX bar coefficient. What is the AX bar coefficient? We are applying the partial derivative with respect to the y. E power x is a 0 and y is a 1. Plus AZ bar here. AZ bar is dou y by dou y. So cos alpha x. So y derivative is a 1 minus, and here with respect to the x, AY bar coefficient, e power x derivative is a e power x, and the minus into minus here the plus, not the minus, here the minus you can write first of all, and with respect to the z there is no any z term, a 0. That is equal to ax bar plus minus e power x into AY bar plus cos alpha x into AZ bar. So AZ bar coefficient is a cos alpha x, AY bar coefficient is a minus e power x, and AX bar coefficient is a 1. Okay, my dear students, now we can apply the cross product. AX bar coefficient is a 1, my dear students. AY bar coefficient is a minus e power x, and AZ bar coefficient is a minus is already there. Sorry. See here there is a minus is there. Write that minus cos alpha x AZ bar coefficient. On YZ plane, x is equal to 0. Okay. X is equal to 0. The J bar on the YZ plane is AX bar minus e power 0, because it's x is equal to 0. E power 0 value is a 1. So minus AY bar, and cos 0 value is a 1. This is 0 degrees minus AZ bar. Okay. So AX bar minus AY bar minus AZ bar ampere per meter square. Got it? Then the next example, given the general vector A bar is in the A phi direction, sine 2 pi is the coefficient. In the cylindrical coordinates, find the curl of A bar at 2 pi by 4 and the 0. Cylindrical coordinate system is, what is the coordinates here? R, phi, and the Z. These are the coordinates. They're asking for the del cross A bar. Del cross A bar is equal. Okay, and we have the A bar is there, and other point is there, A bar at the 2 pi by 4 and the 0. So first of all, you can write that it's a del cross A bar is equal to. What is the del cross A bar? AX bar, AY bar, and AZ bar. Del dou by dou x, not the dou by dou x, sorry. This is the cylindrical coordinate system. The cylindrical coordinates means AR, AY, A phi, and AZ. AR bar, A phi bar, and AZ bar is dou by dou R, dou by dou phi, and dou by dou Z. What, my students? And what is the function? Is the phi only. The phi is A bar is equal to, A bar means AX, actually it is a AR, A phi, and AZ. What is the AR? This is a AR bar coefficient. What is the A phi bar coefficient, and what is the AZ bar coefficient? So we have only the A phi coefficient only. So the AR bar, A phi bar, AZ bar, and dou by dou R, dou by dou phi, and dou by dou Z, and AR bar there is no any term, and A phi bar is a sine 2 pi to phi and 0. So AR coefficient here, the 0 is there, and A phi coefficient is 2 cos sine 2 phi, and AZ is a 0. That is equal to. Now I am taking that is the AR bar into. So AR bar means these two functions. Dou by dou Z of dou by dou Z of, that is a minus of dou by dou Z of sine 2 phi. That is the AR bar coefficient minus A phi bar coefficient. A phi bar. A phi bar means these two. Both are the zeros on. The 0 minus 0 plus AZ bar coefficient. What is the AZ bar coefficient? You get dou by dou R of sine 2 pi minus 0. Minus 0. Got it, my students? See, whenever if we can apply here the ER bar, dou by dou Z, here there is no any Z component. Z term. So dou by dou Z of sine 2 pi is constant derivative is a 0. So AR bar coefficient is a 0. Already the 0 you'll get in the A phi coefficient. But AZ bar, you can get here the AZ bar is a dou by dou R of sine 2 pi. Sine 2 pi. But in this function, they're saying that 1 by R is the term is there. 1 by R term dou R into A phi bar coefficient is a sine phi. See, whenever if it is in the del square AR bar, del cross product in the cylindrical coordinate system, since the 1 by R is multiplication the first factor, because it is a 0, it is not getting in this one. And here the 1 by R into dou R into A phi bar. So dou R into A phi bar, R the value is multiplied with the sine 2 pi, then you can apply the dou by dou R. So dou by dou R means sine 2 pi will get having the AZ bar coefficient. So the del cross H A bar is equal to 1 by R into R coefficient is a sine 2 pi and is a AZ. Okay, the given the points is 2 pi by 4 and the 0 is R, and this one is a phi and it is a Z. So del cross A bar is equal to 1 by R, we got 1 by 2, and the sine 2 pi, the phi is pi by 4 into AZ. So del cross A bar is equal to, we got as a 1 by 2, and it is get cancel of sine 90 is a 1 into AZ bar. So del cross A bar is equal to 1 by 2 AZ bar. 1 by 2 AZ bar. Got it, my students? In the whenever you can get it is a 1 by it is a 0.5. See what is the difference here in the cylindrical coordinate system. Whenever there is a R and a D phi, we'll get the del cross A bar is equal to 1 by R. The term is multiplication factor here. And similarly, for this function also the 1 by R into A phi. R into A phi bar also. Got it, my students?